Okay, the question looks really easy right now, but as we always say, the question is always simple, the answer is the difficult one. Anyways, question number 3. A body initially at 80 degrees Celsius cools to 64 degrees Celsius in 5 minutes and to 52 degrees Celsius in 10 minutes. So, the temperature of the surrounding is how much? Option A, 26 degrees Celsius. Option B, 16 degrees Celsius. Option C, 36 degrees Celsius. Or option D, 40 degrees Celsius. Yup, we know you did it right. It's option B, 16 degrees Celsius. Really great, awesomely well done. Okay, so this looks difficult even for me. Anyways, question number 4. A wave packet with center frequency omega is propagating in dispersive medium with phase velocity of 1.5 into 10 to the power 3 meters per second. When the frequency omega is increased by 2%, the phase velocity is found to decrease by 3%. So what is the group velocity of the wave packet? As I said, yes, seems difficult, but you can definitely do it. Option A, 0.25 into 10 per 3 meters per second. Option B, 1 into 10 per 3 meters per second. Option C, 0.6 into 10 per 3 meters per second. Or option D, 0.75 into 10 per 3 meters per second. And yes, you are damn right. It's option C, 0.6 into 10 per 3 meters per second. If you could do it, very well done. Also, check out the solution. Great job. Moving to question number 5. A communication satellite of 500 kg revolves around the Earth in a circular orbit of radius 4 into 10 power 7 meters in the equatorial plane of the Earth from west to east. The magnitude of angular momentum of the satellite is option A, approximately 0.13 into 10 power 14 kilogram meter square per second. Option B, approximately 1.3 into 10 power 14 kilogram meter square per second. Option C, approximately 0.58 into 10 power 14 kilogram meter square per second. Or option D, approximately 2.58 into 10 power 14 kilograms meter square per second. Oh my god, the options are pretty big. Great, so I believe you have done it. It's definitely option C, approximately 0.58 into 10 power 14 kilogram meter square per second. Okay, I'm tired. But great job guys, congratulations. I hope you are not tired as well. Let's go ahead. Just 5 more questions to go. Question number 6. For MRI, a patient is slowly pushed in a time of 10 seconds within the coils of the magnet where magnetic field is B, which is equal to 2 Teslas. If the patient's trunk is 0.8 meters in circumference, the induced EMF around the patient's trunk is how much? Option A, 10.18 into 10 power minus 2 volts. Option B, 9.66 into 10 square volts. Option C, 10.18 into 10 power minus 3 volts. Or option D, 1.51 into 10 power minus 2 volts. Okay, this seemed like an easy one, and I hope you have done it in enough amount of time. So option C, 10.18 into 10 power minus 3 volts is the damn correct answer. Congratulations, very well done. Okay, so this looks like the most shortest question we'd had till now. Okay, question number 7. The measurement of voltmeter in the following circuit is option A, 2.25 volts, option B, 4.25 volts, option C, 2.75 volts, or option D, 6.25 volts. What do you guys think? Seems like a very easy question. Yes, it is. The correct answer is option A, 2.25 volts, and yes, you got it right. Very well done. Let's move on to the question number 8. The change in the gravitational potential energy when a body of mass m is raised to a height of nr above the surface of the earth is, in brackets, here r is the radius of the earth. Option A, n upon n plus 1 into mgr. Option B, n upon n minus 1 into mgr. Option C, nmgr. Or option D, mgr upon n. Okay, as compared to the previous question, this looks difficult, but I hope you are smart enough to do it. The correct answer is option A, n upon n plus 1 multiplied with mgr. Good job. Don't forget to take the solutions. Take a screenshot of all the solutions if you can, as well as the questions, or download the video as you feel comfortable. Question number 9 on your screens. A current I is flowing through the loop. The direction of the current and the shape of the loop are as shown in the figure. The magnetic field at the center of the loop is mu naught I upon r times, where MA is equal to R, MB is equal to 2R, and angle DMA is equal to 90 degrees. So what do you guys think? Option A, 2 upon 16 but out of the plane of the paper. Option B, 5 upon 16 but into the plane of the paper. Option C, 7 upon 16 but out of the plane of the paper. Or option D, 7 upon 16 but into the plane of the paper. Okay, too many papers. The correct answer is option D, 7 upon 16 but into the plane of the paper. Very well done. Great job. Moving on to the final question for today. I really hope that you have done all the questions right till now. Even if you have not done it, do not worry. You are awesome. Question number 10. A 2 cm tall object is placed 15 cm in front of a concave mirror of focal length 10 cm. What is the size and nature of the image? Option A, 4 cm and it's a real image. Option B, 4 cm and it's a virtual image. Option C, 1 cm and a real image. Option D, one of our favorites, none of these. What do you guys think? Hope you got the last question right. The correct option is 4 cm and the image is real.